Hi Jerry, where is Peter?
Yeah, I'm chatting with him.
Uh, Please tell him to get in soon.
Yes.
Thank you.
所以基本上，等一下第一阶段的时候，当然你要听 Peter 讲也可以，可是我想咱们已经比较清楚那个文法长怎么样了。所以其实那个时候你可以先把头或把麦克风给关掉，如果你想做其他事的话，等到那个 Peter 那边结束之后，再轮到咱们，大概就是20分钟、20分钟到40分钟吧。就这样也可以提前跟你讲一下。Join cool. Oh, it look like ve- very like the situation that happened yesterday, and I wonder, and because in about half of the meeting progress about half, and if I recall correctly, people always got their connection stable, so I have no idea what's going on here. I can just hope for that he can resolve this in the next 8 minutes. And
This is always happening to the main host.
yeah, we cannot hear him, and maybe it's due to. Hazel, are you a technical person, or if you can, you can just do that because it sounds like Peter and Oris are in Eastern Europe. One in Poland, I forget where Peter is located at. And according to them yesterday, their home network, both home network and cell network has issues, and goes without the interference of firewall and antivirus software. So I would say that maybe your backend, your cloud service provider, has some routing issues with people in Europe, or if you are using P2P structure, there is some certain cases you can try to improve that. Of course, that is. Oh, hi, Peter.
Peter.
Nice to see you again.
Hi.
Can you hear me now?
Yeah.
Yes, correctly.
Awesome. Seems like Europe is blacklisted.
Where the address got blocked in your country? Is that possible, or it is
No,
just routing
I
issue?
can hear you. I can hear you. I can see you, but seems like my video doesn't go out.
Now your video is showing too, so no worries.
Awesome.
Okay, Peter. Peter, hi. I am Hazel, the moderator of today's workshop. The quick com host has just sent you a Drive folder link in the chat box. Can you please access that and get your name badge with your name on
Okay.
it? Cool.
Let me just quickly switch to another browser. I'll be right back.
All right.
It is her. I got notified by one of our team member that we have echo in our YouTube video feed, but I do not hear echo in the meeting room actually. So please check in with the video feed to see what's the problem there.
All right. Tito, help me out, all right? Sorry.
Hazel hỏi gì vậy?
Để xin. Cái gì nhỉ?
Is Peter down again or presenting?
Okay. Jerry, you were asking about the video presenting on YouTube, right?
Yeah, it is stopped the echo. Yeah.
Yeah, I think everything runs quite smoothly on
Okay.
YouTube yesterday.
Okay. So maybe it's just false alarm.
Okay, Peter, please change your name patch. Oh yeah,
Oh, you can.
here
Yeah.
it is. Thank you.
Yeah. Do you mind if I try the screen sharing?
Of course. Please.
Go ahead.
Just FYI
Can you
for
see it now?
yesterday, we cannot see it now.
Okay, I will have to restart. Just a moment.
Okay. So for yesterday, we've got about 50 to 60 people and peak 1,400 people on YouTube. As a technical screen, I would say that it's a really good result. So I don't know how many participants will be there today, but let's hope that the people remaining are very enthusiastic about the tech stack, so we get to interact with them directly. Yeah, so let's wait for Peter.
He is out for a moment.
Yep.
Okay. I just want to double check with you guys. Let's see if I'm saying your names right. All right. I believe Peter is Peter Garamvölgyi. Uh-huh. Jerry Ho, Xin Chen.
Yeah.
Is that enough? Huan Liu,
Yeah, I'm here.
and Wei Fan Ho.
Hello.
Okay, okay, all right. Correct me if I'm wrong.
No worry, you pronounce it well.
Great. Okay, Peter is back. Okay.
Yes, we can see you now, and the name badge is working well. So let's try screen sharing.
Okay. Peter, are you ready?
Yes, we can see that perfectly. Oh, cool.
Awesome. Okay, everything is set. Thanks
All
for
right.
the assistance.
All right, so let me go through the flow of the agenda first. I'll introduce each of you guys, and maybe I will introduce a little bit about East Vietnam 2022 and the Build-a-thon, the main activity, and then I will let Peter introduce yourself. Yeah, please, and then you can jump right directly to your presentation. All right. Okay, 1 minute to go. We are currently having 23 participants.
Yeah, I already saw some familiar faces from yesterday, so good sign.
Yeah.
I mean, there is
Let's
even a
see.
Japanese name participant.
So it is a good sign we are attracting more people.
Yeah, more target oriented. Yeah, 1 minute.
1 minute. Chị Thơ, could you please set the poster, the banner of the workshop?
Sure, you mean the slides?
Okay, let's wait until we reach 30 participants so that we can start and nobody will miss anything. All right. Are you ready, guys? Participants? All right. Anyway, I think we may start now. Are you guys ready? Okay. Hi, everyone. Welcome to our workshop number 3 of East Vietnam 2022. And our workshop today is about dive in deep on scroll infrastructure. With the main host is Mr. Peter Garamvölgyi. Hi, Peter. Hi, Peter. Can you please say hi to all of our participants today? Peter, can you hear me?
Yeah, I can hear you.
Okay. Yeah, okay. Can you please say hi to all of the participants and introduce a little bit about yourself?
Sure, yeah. Thanks for the introduction, Hazel. If at any point my internet is lagging or if there's any sound issues, please let me know. So,
Okay.
hey everyone, very pleased to be here. My name is Peter and I'm from Scroll. So, yesterday, some of you might have heard a great presentation from my colleague Orest. He talked about ZK rollups in general. And since this is a hackathon, we want to give you like more hands-on and more in-depth knowledge about layer twos and also blockchain development. So we're gonna have 2 workshops today. We're gonna have a deep dive into Scroll's infrastructure, and on Thursday we're gonna have a more hands-on like smart contract workshop.
Okay. Thank you, Peter. And also we have other teachers from Scroll, which is our very familiar face, Jerry Ho, researcher at Scroll. Hi, Jerry.
Hi, Hazel,
Yeah.
everyone. It's glad to see you here.
Nice to see you today. And also we have Mr. Siren Chen, Mr. Huan Liu, and Mr. Wei Fan Ho as the engineers at Scroll. Welcome, everyone. Welcome on board. All right. So now, before we jump into the main part of the workshop, maybe may I introduce a little bit about East Vietnam 2022 and a little bit about Build-a-thon. Okay, let me share the screen. Okay. Yeah. Okay. Can all of you see my screen?
Yes.
Yes, thank you. Okay, so East Vietnam is the first hub for blockchain community to build and learn together. And our event is gonna take place from the 25th to 27th of November 2022 at Independence Palace in Ho Chi Minh City, Vietnam. We aim to give you as much experience and knowledge from the top experts in the blockchain industry, like as much as possible, so that everyone can connect with each other, network, and learn from each other. So that is the main point of this East Vietnam 2022 event. And why build and learn? Learning is that we have this current workshop where everybody can join and learn from scroll teachers, top experts, and why build together? Yes, we have the Build-a-thon 2022. Okay, so this build-a-thon has the total reward and bounty and quadratic funding of up to 60,000 US dollars. And this build-a-thon takes place from the October 24th to the 26th of November. The online submission deadline is November 24th, 2022. So please note that down. Register via the link on our social media sites, and remember to submit your prompt, your idea by November 24th, so that you can prepare your best selves on November 25th and November 26th with the demo pitch day in front of all top global VCs at our event. All right. And to get you the best updates, let me show you the link to our Discord. I'll give you about like 2 minutes to scan this QR code, join our Discord server so that you can communicate with Scroll teachers and get assistance from the East Vietnam team. Okay, please scan it, and when you're done, you can chat in the chat box. Type in the chat box, done, and then we'll move on. Okay, on our Discord server we have the channels for all types of prompts from even Scroll, Dora Hikes, and other sponsors, so that you can get the best updates, get the best support. You can ask anything you want, and you can also chit chat and network with other teams as well. It is a great chance to connect and network globally. Okay. After our Discord link, we have a very surprising and impressive gifts for all of the participants that are here joining the workshop. We have the POAP NFT as a gift for 100 participants joining today. So please, right now, scan the QR code to claim your POAP NFT. It is a great chance. This is a rare chance. So please do not skip it. Do not miss it. Okay. You can scan the QR code with your phone using your camera, and then click on the link presenting on your screen, and then that link will guide you to the POA website, and then you can get your NFT link. NFT, I mean. Okay, so to guide you through a little bit, if you have any questions during the workshop, or even for us, East Vietnam, or if you have any questions for the Scroll teachers, please type in the chat box, or you can raise your hands during the workshop so that we can like communicate with each other a little bit. And after the sharing from Peter, we will have like the breakout room session where groups of participants will be put into smaller rooms so that everyone can talk to others about more details, ask anything you want, and get the best support. All right. And to do that, after the sharing from Peter, I will put in the chat box the 4 links to the 4 different rooms by our 4 Scroll teachers, so that you can choose which specific link you want to join in. Okay. And in the breakout room session, if you have any questions, you can type in the chat box, or you can unmute yourself to ask the teacher. All right. I assume that everyone is done with this QR code. And now let's move to the main part. Dive in deep on Scroll Infrastructure Workshop by Péter Garamvölgyi, the infrastructure engineer at Scroll. Okay. Now, Peter, it is your chance to share with all of the participants of this Build-a-thon. Welcome, Peter.
Awesome. Thank you again for the introduction, Hazel.
Welcome.
So I'm showing my slides. Again, let me know if you cannot hear me, cannot see it, and then we can adjust. Yeah, so hey everyone, again, my name is Peter. I'm an infrastructure engineer here at Scroll, and today we're gonna have a deep dive into Scroll's infrastructure. Like Scroll is one of the many layer 2s that you might have heard about. But my goal here is that, first of all, I want to show you how to get started building on Scroll, which might be a good chance for you to build something in this hackathon or build-a-thon. And my other goal is to help you understand how rollups like Scroll work under the hood. So have like a deeper understanding of what's going on when someone says they're bridging assets from Ethereum to a layer 2, or what's going on when you say, you know, a ZK rollup is verifying transaction. So that's the goal now. And again, if you have any questions, you can just type in the chat, and maybe Jerry or Hazel can let me know if there's any questions, and then I can answer those. So before we get started, again, a bunch of QR codes, or you can type in the link. So these are the most important resources for you to get started. First of all, our current testnet is a permission testnet. So if you want to build on Scroll, then don't hesitate. Open this link on the left and just fill the form, register. The most important thing is that we need your address so that we can put you on the whitelist. And once you're registered, you can start deploying on Scroll. So this is, if you're thinking of building on Scroll, then please fill this as soon as possible so that you can get access. And the link on the right is guide.scroll.io. It's basically an end-to-end guide to our testnet, like how do you register, how do you get tokens, how do you use the bridge from layer 1 to layer 2. So all of these you can have, you can look at detailed documentation and you can find all the links here. So if you're interested, just go ahead and check out this website. And also if you want to reach out to me, you can find me on Twitter anytime. I'm welcoming DMs. So just want to start with a quick recap, what is a rollup. So as I mentioned yesterday, my colleague had a great overview about ZK rollups and what we're doing at Scroll. But basically, rollups are state-of-the-art scaling solution to Ethereum. So many of you might be familiar with development on Ethereum, and you know that it's secure, it's decentralized in many aspects, but scalability has been an Achilles heel of blockchains in general and of Ethereum for a long time. So there have been different scaling solutions explored over the years. So we have state channels, we have Plasma, sidechains. It's really been a thriving research area. And so far, the solution that we arrived at in the Ethereum community are rollups. So rollups seem to have the best properties in terms of safety and scalability that they can offer. Now, there are different types of rollups. There's optimistic rollups and there's ZK rollups. But the basic idea of rollups is that you still put data on layer 1. So all the transaction data gets on Ethereum as it did before. But the change is that you don't need to execute all transactions. So instead of having this very expensive step of, thousands of machines all around the world participating in Ethereum, they all execute all the transactions and see all the results. Instead of that, you can have a much simpler step. So in the case of ZK rollups, instead of executing transactions, you just have a proof, which is much cheaper to verify and much smaller to store than all of the transaction execution results. So that's basically the basic idea of rollups. Let's dive more deeper into how this works in practice. A bit about Scroll. So Scroll is an example of a ZK rollup, and it's a ZK EVM, as we call it. So it's a scaling solution for Ethereum. When you say ZK rollup, you might think about zero knowledge. Maybe it's about privacy. That's a common misconception. So ZK proofs can be used for privacy, and I think that's a very exciting application, and maybe something that you can look into in this build-a-thon. But for us, zero knowledge technology is only used for scaling. It's basically a compression technology. So compress a large computation into a small, easily verifiable proof. That's basically what ZK rollups do. So Scroll is a ZK rollup, and Scroll is building a ZK EVM. So that means that our goal is not to create a new virtual machine with a new programming language with all new properties. What we want to have is something that feels exactly the same as the EVM, feels exactly the same as Ethereum. So if you develop on layer 2, you use the same tools, same languages, same kind of workflow, but under the hood, we verify each and every EVM instruction in the ZK EVM. So this is a very challenging task technically because EVM is very hard to verify. It's a very complex, let's say, relatively complex virtual machine. But this is what we're aiming for. So if you see in the news the term ZK EVM, what you need to understand is basically a ZK rollup that is EVM equivalent. And many projects are building different ZK EVMs, and Scroll is one of these projects. And before we want to jump into this, So maybe I can introduce myself a bit more, and you can see me, but I cannot see you. So I think it would be nice for you too if you want to introduce yourself. So I want to invite you to maybe post in the chat if you want, maybe a sentence or two introducing like who you are, what is your experience with Web3 or Ethereum, so that we can also have a better understanding of the audience here. So again, I'm an infrastructure engineer at Scroll. So at Scroll, the very heart of the system that we're building is the ZK EVM. And we have a very talented group of zero knowledge experts, researchers, engineers working on that. Also, it's built together with the Ethereum Foundation. Now, what I do is not the zero knowledge part. What I do is everything around the zero knowledge part. So all the other components, which is the sequencer, which is the blockchain node, the components connecting layer 1 and layer 2, which is the bridge, and also the components connecting Scroll with the provers. So there are different components in this system that you will see in a moment. And I'm working on making these more robust, scalable, and basically being able to support the ZK EVM. So for the rest of the time, first I want to show you how to get started on the pre-alpha testnet if you want to develop, deploy stuff. Then we're going to look into the architecture of Scroll, and we see basically the workflow, like what happens when a block is created, what happens when a transaction is created, how does it all come along into one whole. So for getting started, I want to show you our pre-alpha portal. Hopefully you can see the pre-alpha portal now. So if you go to pre-alpha.scroll.io, this is the entry point of our testnet. And if you cannot open this might be because you're not on the whitelist. So again, make sure to sign up with the link that I showed you. I will show it again at the end. And once you are on the whitelist, you can see this site. And basically what you want to do is very simple. First of all, I believe many of you, or probably all of you, are familiar with MetaMask, which you would use for development, sending transactions. What you need to do is you need to add these networks to MetaMask. And the easiest way would be to just, click on this link. There are two networks. One is the layer 1, which on mainnet is going to be Ethereum, but in our case, we run like a test layer 1. And there is the layer 2 network, which is Scroll itself. So you can just click on these buttons to initialize your MetaMask. And the next step would be to get some test tokens. So we're operating a faucet for this. And the way it works now is that you just go to faucet, you click on request, and it will send you some tokens on layer 1. So you receive some test ETH, and you also receive some test USDC. So these are just test tokens on our layer 1 testnet. And there's one final step you need to take before you can start building your Scroll. You need to bridge these tokens from layer 1 to layer 2. So this is the same experience if you did any token bridging between different chains. Usually it's very similar UI, similar experience. You need to choose, the source chain is layer 1 testnet. The destination chain is layer 2 testnet. You can choose which token you want to transfer and the amount, of course. And after that, you basically just confirm the transaction as you would do on any other EVM chain. So just use MetaMask, make sure all the information is correct, and it's confirmed. So at this point, I send a transaction to our bridge, and it takes usually around a few minutes, like maybe 2 minutes, for it to arrive on layer 2. So if you want, you can check the blockchain explorer, you can check the transactions as you would do on Etherscan or any other blockchain explorer. There's a blockchain explorer for layer 1, and there's a separate blockchain explorer that looks exactly the same for layer 2. And you can check the transactions here. And if you follow these steps, again, get some tokens on the faucet, bridge those tokens from layer 1 to layer 2. Then at the end, in your layer 2 wallet, you will have some test ETH. And at that point, you can just get started and start deploying contracts on Scroll using whatever you want to use. You can use Remix, Foundry, hard hat, whatever you're used to using, it works exactly the same way on Scroll. There's some other things that you can play around with. So we have a proof of concept decentralized application running on the testnet, and this is a Uniswap home. So basically, you can swap tokens between 3 different tokens. And so the cool thing about this is that this is all running on layer 2. This is all running on the ZK EVM, and all of the transactions that you send on layer 2 are secured by zero knowledge validity proofs. So the cool thing is that this all happens, but the other cool thing is that you don't need to know. So from your perspective, it looks exactly the same as if you were using Uniswap on layer 1. It's just faster and cheaper. And the last component on this portal is the Rollup Explorer. This is basically a blockchain explorer that connects the 2 layers. So it talks about the status of layer 2 blocks on layer 1. And this is something that I will go into more details in just a minute. So to go back, I just wanted to quickly show you, because many of you might have already started building or coming up with ideas. Many of you are planning to build something. So if you want to get started on Scroll, please first of all sign up on the form, and second, go to pre-alpha.scroll.io, and then you can just start building as you would build on many other chains. So hopefully that's all clear. And yeah, let's dive into the architecture of Scroll. I showed you, I can just show you one more thing. So let me show you how to send the layer 2 transaction. Basically, you can open MetaMask, that's one way to do it, and just send a transaction right in MetaMask, choosing the layer 2 testnet. So we send a transaction to myself. And you can just confirm it is the same flow as you would do on layer 1. And if I view it on the blockchain explorer, you can see that it's a layer 2 scan, layer 2 explorer. It's already confirmed. It was quite fast. And yeah, that's it. So it works. It's exactly the same experience as on Ethereum, but it's on a ZK rollup. So that's kind of the cool thing. And I wanted to show you this so that now that we kind of see what's under the hood, what happens when I send a transaction, what's all the processes and components that you cannot see. Now you know what we're talking about. So what happens when I send a transaction? That's the end goal that we want to go into. But I want to start by looking at the components of the system. What are the different components that I briefly mentioned before that make a ZK rollup possible? And on a high level, there's only 2 components. So there's a layer 1 component running on Ethereum, and there's a layer 2 component. So the layer 1 component is a smart contract. It's a normal Solidity contract that you would deploy on Solidity, deploy on Ethereum, deploy on layer 1. And this is used to store data from layer 2 and to verify proofs from layer 2. And the layer 2 node, you can just think of it as a blockchain node. Actually, a big part of our layer 2 node is a fork of Go Ethereum. So Go Ethereum is the most widely used execution client for Ethereum. And for compatibility, we just fork it and modify some parts of it, but most of it is the same as Go Ethereum. The layer 2 node is a blockchain node generating blocks. And yeah, it just receives transactions, submits data to layer 1 for data availability, and periodically submits proofs so that the layer 1 contract knows which transactions on layer 1 happened and that they happened correctly, executed correctly. So if you're just developing on Scroll, this is basically all you need to know. You don't need to know how the layer 2 node works. You don't need to know how the smart contract works. You just need to know that you connect to the layer 2 node, you submit transactions, and then you can start building. And basically, this supports the same APIs as the standard Ethereum API. So here I use a curl RPC request. So some of you who might have use the JSON RPC from Ethereum might be familiar with, ETH chain ID and these methods. These are the standard Ethereum APIs that you can use. And here you can see I can call it on pre-alpha scroll.io layer 1. And I can also call it on pre-alpha.scroll.io layer 2. So this is the layer 2 endpoint. So you can use it with curl, but this also means that you can use Remix, Hardhat. You can use basically all Ethereum tooling on Scroll because it provides the same API. So this is all you need to know, but let's try to understand it better. So zoom in a little bit and see the exact component these consist of. So actually we have two smart contracts. There are two main smart contracts. So one is the bridge contract, and the bridge is what we just used when I showed you that I was bridging assets from layer 1 to layer 2. I was actually sending a transaction to the bridge contract on layer 1. The other contract is the rollup contract, and this is what basically realizes or implements the rollup work, so storing data, storing proofs, etc. The layer 2 node also consists of multiple components. So we have three main components: the relayer, the sequencer, and the prover. So the relayer, I'd say it's closely connected to the bridge. The relayer is the component that relays messages from layer 1 to layer 2. So that's when I bridge assets from layer 1 to layer 2. And also it can do the other way around. So relay message from layer 2 to layer 1 when I want to withdraw my assets to Ethereum. So that is the job of the relayer. The sequencer is the Go Ethereum fork that I mentioned to you. So the sequencer is basically a blockchain node. It collects the transactions and it creates blocks. So just as on layer 1, you have blocks created every 12 seconds. On layer 2, we also have blocks currently created every 3 seconds. And they look the same as on Ethereum. It's just basically a different blockchain. So generally speaking, rollups, you can think of rollups as an independent blockchain. So they have their own data, their own nodes. But the thing that makes rollups secure is that all this data is committed to layer 1 and validated on layer 1. So it's not a fully independent blockchain. It's a blockchain that's validated by Ethereum. So that's what the sequencer does. It creates the block. And the prover creates the zero-knowledge proofs for each block or each patch block. Now with the prover, we can continue zooming in and see all the components of the system. The actual component that creates the proof is called the prover, or we call it the roller. So a roller is a relatively strong machine, so you would need a lot of memory and a bunch of GPUs. So currently it's still a quite expensive process to generate these proofs. But this is what the roller does. So basically the roller gets the data from the sequencer and then generates the zero-knowledge proofs. And in our case, which might be somewhat unique to Scroll, we have a decentralized prover network. So that means that we have an unbounded number of provers. And basically, if you have hardware, you can always join as a prover or as a roller. So this is, I usually compare it to kind of proof of work, where if you have the hardware, you can become a miner and you can create blocks and earn money. So here you can create zero-knowledge proofs and earn money. So in this way, it's similar to proof of work, but it's also quite different because first of all, it's not really the same way of reaching consensus. But more importantly, this is not wasted work. So proof of work, you need to do a lot of random computations, like computing hashes, for instance. That doesn't really do anything apart from making it hard to create blocks. But in our case, we are producing something that is useful by itself, which is an independently verifiable proof of the block's execution. So I think this may be more similar to proof of useful work, which was a term that some people used in the research community. And the missing component now is the coordinator. So who decides which roller creates the proof, which roller has a chance to earn the rewards? This is done by the coordinator. That is the missing component between the roller and the sequencer. So we talked about the contract, the relayer, sequencer, coordinator, and the roller. So these are the main components of the system. And let's just see kind of a timeline of what happens when a block is created. So for each block, we have an execution trace that kind of captures all the information about the block's execution. So which opcodes were executed, what were the transaction, storage accesses, all of these are captured in the trace. I'm just checking just a moment for the questions and that I'm still online. Okay, looks all good. So it all starts by getting this execution trace. And from this, we kind of convert it into different formats. And we use this as the input to the zk-AVM. On the zk-AVM, you can think about it as one component, but it actually consists of many different components, and different components create proofs for different parts of the execution. So for instance, we have the EVM circuit that proves that every opcode that was executed correctly. Like, I guess it updated the stack correctly, had all the side effects, and no more side effects than it should have had all these information. The storage circuit, on the other hand, verifies the storage updates. So when you deploy a contract, it gets written into storage, it creates a new node in the storage tree, or if you update the state of the smart contract, it might update value from one value to another value. So all of these state transitions are proven by the storage circuit. And then we have many other different circuits proving different things. It's quite complex. And finally, once we have all these independent proofs of different aspects of the block, now we need to aggregate this into a single proof. So we don't want to have too many proofs. We want to kind of compress it down to a single proof. So that is the job of the aggregation circuit. And the output of this whole process is the proof for the block. So the input, again, is a block, a layer 2 block that has a bunch of transactions. The input to the circuit is derived from the execution trace of this block. And the output is a very succinct, very small, and easily verifiable proof that basically this proof gets submitted to layer 1. So the smart contract, it's so cheap that even the smart contract can verify it. But in theory, other people could also verify it. So this could also be used outside of the ZK rollup. So we talked about different components of the ZK rollup, and we talked about the proof, time flow. And now I want to put it all together into basically an end-to-end workflow. So at a bird's eye view, at a very high level, what happens is that we have two blockchains, and the block data from layer 2, scroll in this case, gets committed to layer 1 periodically. So let's say in this example, we have batches of 6 blocks. All the data gets written to Ethereum so that it's available to everyone. So we submit the block data and we submit a validity proof along with this data. So this proof proves that we executed all these blocks correctly and we arrived at the correct state root at the end. So in our case, these two commitments are actually separate. So first we commit the block data because we can do that very quickly. As soon as the block is available, we have the data, so we can submit it to layer 1. The validity proof, we have to generate a zero-knowledge proof for that. So that takes a longer time. So it might take an hour or tens of minutes. So that is going to be committed a few blocks later. But this doesn't change the basic idea that we commit these two things to Ethereum. So this means that a layer 2 block can have different, it's kind of like a state machine. It can have different states. So the first state is pre-committed. So the block is already created. We have the block with the transactions on layer 2, but it only exists on layer 2. So layer 1 doesn't know about this block. This is when the block was just created. And this means that this is not finalized yet. The next stage is when we actually commit this block. So we take the layer 2 data and we write it to layer 1. We submit it to the rollup contract. And this is what we call committing. So basically the transaction data is already on layer 1, but this is not verified yet. So the execution might still not be correct. And finally, we submit, now we have the data, finally we can submit the ZK proof, the validity proof, and the smart contract on layer 1 will verify this proof, and if it's all correct, then the block status is updated to finalized. So finalized blocks are really truly finalized, so as long as the layer 1 block cannot be reverted, and with proof of stake on Ethereum, we now have good finality, not just deterministic finality. So when it gets finalized on layer 1, it's basically like that forever. There's virtually no way to revert your transaction. And this property is very important for many applications, that you can be sure that maybe after 10 minutes, your transaction cannot be reverted. By the way, if you heard about optimistic rollups and ZK rollups, I think the most crucial difference is the finalization time. So both of these systems can finalize transactions, but for optimistic rollups, you need to have a waiting period. I think it's called debate period or something like that, or there are different words for this. You need to wait for that amount of time before it can be finalized, and it's a pretty long time, so it's usually like a week or so. And on ZK rollups, this is maybe an hour or even lower, so it only depends on the proving capacity and the proving technology. So the finalization time is basically much better on ZK rollups. So putting it all together, now I have a graph with the timeline. So time goes from left to right, and we can see the interaction between different components. So we have the sequencer, and now we have a new block, and it means it's pre-committed. So it only exists on the sequencer. None of the other components know about this block. And at this point, we can already commit the block to the rollup contract. So the block data is submitted to layer 1. So the status of this block is updated to committed. So this is already a block that is known by layer 1. So once we commit to the block, we can start generating a proof for it. So the coordinator generates an execution trace, and it chooses a roller and assigns this task to this roller. And the roller can start the proof generation process, which is something that might take, as I said, maybe 10 minutes, something like that. This is something that we expect to improve a lot. I think there's more potential, a lot of projects using ZK technology. So hopefully in the next year, few years, this technology will get faster and faster. In our case, it's already much faster than we thought it would be. So even just five years ago, we thought that the ZK VM would be impractical because it would be too slow. So possible, but impractical. But see, now we're here in 2022, and we are building a ZK VM that actually works in practice. So there's been a tremendous improving time. And I think this process is hopefully going to continue for the coming few years. So this proof generation is still the slowest part of the system, but it's pretty quick. And the sequencer keeps generating blocks, keeps committing them to layer 1, and the coordinator will assign different blocks, different rollers. So we have many concurrent proof generation sessions like this. So in this case, we have 3 proofs, and at some point, these 3 proofs for the 3 blocks, 1, 2, 3, are generated, sent back to the coordinator. And as I said, maybe instead of submitting proofs one by one, which would be correct, but it's a bit wasteful, or I would say it's a bit slow. Instead of doing that, we aggregate different proofs in another aggregation step into single proof. So here now we have an aggregated proof for 3 blocks, and that is what we submit to the rollup contract. So you see there's a gap, kind of a time period between committing the data on layer 1 and committing the proof to layer 1. So there's a time period between that. But once we submit the proof and it's correct, all these blocks will be finalized, so they cannot be reverted. So it's kind of the end-to-end kind of workflow ZK rollups, and I hope seeing this graphic, kind of walking through this, makes it easier for you to understand what happens under the hood in a ZK EVM.
Hi, Peter. Do you mind if I stop you for a while because there have been like a lot of questions for you?
Sure, yeah, we can take some time for a question.
Okay, so let's start with the first one.
So let me wrap up those questions for Peter. So
Okay.
stops in the chat section. He say that hey, currently we are having a very centralized POW. I mean a file before, but for ZK ROAS, will it be the same centralization level? I mean in the end, if there we have to join the mining pool, and in order to able to produce in mini I mean, within time, what will not cut it, etc., etc. And that is his first question. And for his second question, he mentioned that in your diagram before, there's 6+6+6+. You are committing them in.
Can you hear me now?
Yeah, we can hear you
on
now.
my side, Jerry's voice just broke.
Okay, so maybe you can just check the chat session and answer yourself. Sorry. So please instruct Peter to read the questions in chat directly.
All right, Peter, I think you can stop sharing screen for a moment. That will help the hearing and video sharing better. Peter, can you hear me? Hi, Peter.
Oh,
I think he's out for a moment. He will be right back.
Okay. The question I can answer that for now. He asked, for roll up by Arbitron, you can withdraw funds even if the sequencer goes down. Is that possible with withdraw? Yes. On L1 we have a feature called emergency exit, and that one is important. I mean, it's a must to have for every roll up network. I mean, if you cannot guarantee your funds to be secure, what is the purpose of layer 2? Correct? So yeah, for every L2 optimistic rollup or ZK rollup, they have emergency exit function where you can withdraw from on certain satisfying certain conditions like the sequencer enough response or after a given set of block has passed, you can withdraw funds from L1 without your funds being locked in the layer 1. So Peter, can you hear us? Can you hear us now?
Yeah, I can hear you.
Yeah, Steph asked a question in the chat. Maybe you can answer that too.
Go ahead and answer the previous question.
Yeah, please.
Yeah, probably you can hear me, but I can't hear you. It's a one-way communication.
So you can just answer the questions in chat, please.
Hi, Jerry. I also gave you the list of questions from both YouTube and QuickCom. Please check and give Peter an overview.
Okay, sure, thanks. Okay, so Peter can hear us for now, so maybe I'll step in and answer some of the other questions. Okay, so if we already apply to a test net, should we apply again through this link? Yeah, you can think of this link as a fast lane. If you apply to that, we'll be processing that in the topmost priority, so you get to use our full set on our testnet maybe just tonight or earlier tomorrow. So yeah, please definitely apply this link too. And for the second question, you have been working in Web3 for about a year and more of an observer for the previous several years. And he wants to do learn more about ZK tech and Web3 data processing. And yeah, on that topic, we Swirl and some of the other organizations like ZK Hack, 0xPath, or even our friends like software or like Microsoft, like Aztec, or even Polygon from his team. We're all providing a series of workshops or hackathons or grants that can help you from the uttermost beginner level to intermediate level to the expert level that you can learn then in a different set of lessons. And there's also chances for you to secure grants and even enter mentorship programs so that people will get mentored and eventually find a job or find investors. So yeah, there's plenty of chances. And for the other questions, like different. Oh, this question is a little bit complicated. In a decentralized layer model, will a single layer be responsible to publish multiple constructive blocks or lead proofs of each block? Will be published by a different layer. Hopefully my question makes sense. Of course, your question makes total sense. And in that question, currently for different coordinator, layer concept, in a sense, consensus building mechanism, people are doing it in very different ways. Like for, if I recall correctly, in software they are using a variant of Tendermint, but in Scroll, it is not that I cannot talk about that right now. It is that it is currently under investigating right now, because the most important thing in that situation is that we wanna, in a sense, to prevent or in another way to embrace an EV, but in the same time we wanna make it censorship resistant. So yeah, a combination of incentive mechanism and consensus mechanism has to be made in order to make that possible. So it is a little bit too early to talk about that right now, I'm afraid. But if you can come across to our Squirrel Discord channel, I'm sure that some researchers in our team will be more than happy to share with you the current progress on that given topic. So is Peter back now, or is he still trying? Oh, it seems that he's still trying to connect back to us. So in the meantime, let me see if there is some other questions. So it is true if I say Web3 equals to Web2 plus wallet. I would say it depends, because I mean, since you are in this workshop, I am pretty sure that you. Oh, hey, hi Peter, you are here. Can you hear me?
I can hear you.
Oh, good. Welcome back. So yeah,
Sorry.
so it's okay.
Technical problems.
Yeah, technical problems happening all the day. So is to the whole layer 2, and yeah, we're trying to make it better. So for the last few minutes, I've been answering questions from YouTube, and there is some questions that is left. And for one, stop at, is 6 blocks just an example, or is there a set number of transactions or blocks that are always committed?
Okay. Maybe I'll go ahead and answer the previous question first. So you asked a very interesting question, like I showed the rollers and I compared the rollers to proof of work, and some of the guests asked, is it gonna be a centralizing force just as in proof of work? I think this is a very important question and something that we have to think of very, very hard. So when you talk about centralization in ZK rollups, there are different parts of it, right? So there's centralization of the rollers, centralization of the provers. That's one thing. Centralization of the sequencer, that's another thing. So we have to kind of decentralize these, all of these to really be decentralized. So the way we think about the rollers is that we don't want to have the same kind of mechanics as in proof of work. You know, in proof of work, it's always the fastest or the strongest machine wins. And that means if you have the strongest machine, you get more rewards, you put more investment into your machines, and this is a really centralizing force. We're trying to kind of adjust this design to make it lessen this effect of centralization. So one idea that we have is that it's not always the fastest that wins. So maybe you have like a window for proof generation. Maybe you have like 10 minutes and we choose like 3 rollers. And even if you're not the fastest, even if you're the slowest, but you still finish the proof generation within 10 minutes, you can still get the reward. So I think to answer this question, by tweaking kind of the crypto economic design, we really hope to avoid decentralizing forces and make this cloud network more decentralized. Now to get to your other question, someone asked, is 6 blocks just an example or is it some specific constant that we have? Yeah, so 6 block was just an example. Currently, we commit every block one by one on layer 1, but as a very important optimization, we want to have this batching that I mentioned, for example, 6 blocks, but this is not going to be like a certain number of blocks. This depends on the amount of transactions, the amount of computation in each block. So the idea is that we have like a gas goal, let's say 1 million gas, something like that, or 10 million. And if there are many transactions in the blocks, then maybe we have only 4 blocks per batch. If the blocks are relatively empty, then we might have 15 blocks in one batch. So this is kind of this dynamic adjustment based on the transaction volume. I hope that answers the question.
Yeah, that makes perfect sense. Thank you, Peter. And yeah, it seems that there's no of the questions from the chat, but you do have the answers, so you can proceed freely to the next part of your presentation.
Okay, thank you. So most of it is already discussed, but I want to kind of have a recap at the end. So we stopped at this point, the end-to-end kind of workflow of block creation on Scroll. And if you go back to the pre-alpha portal that I briefly showed you, then now you can better understand what is the Rollup Explorer. So the Rollup Explorer, you see each layer 2 block with one entry, and you can see the status of the layer 2 block. So the status can be pre-committed, again, if it only exists on layer 2, committed if it's been written to layer 1, and after some time, it gets finalized. So finalization means that the proof has been submitted, and you can also check the transaction where the proof has been submitted to layer 1. So this way you can see basically which are the layer 2 blocks that are finalized and cannot be reverted. Yeah. So just a few words about this testnet that I showed you that you can build on. So this is a testnet that you can play with pre-deployed tabs to MetaMask. As I showed you, you can bridge your assets between layer 2 and layer 1 2 ways. There's a Rollup Explorer to see the rollup status. But now, I think since last month, we also support arbitrary smart contract deployment. So that means you can, as a hacker, you can just build stuff, deploy it, and scroll without restriction if you're on the whitelist. So soon we will have like a completely open testnet, but now we're kind of still ramping up the proving capacity. So we still have a whitelist. And the thing I like to say, which might not be a good thing to say, but kind of the goal is that we try to be boring in the sense that, as I mentioned, Scroll developer experience, user experience should be exactly the same as Ethereum. So EVM compatibility as much as we can. And again, that means you can use Solidity, Remix, Truffle, Hardhat, whatever you're used to developing in. I think that makes it much easier to start developing on Scroll. It makes our life much harder because it's very hard to create this fully EVM equivalent or at a very high level EVM equivalent ZK rollup. So that makes our life harder, but that's what we're working on. And also, there's no cool, shiny technology that you can learn, new languages, stuff like that, because we just inherit the technology from Ethereum. Yeah, I think it has its pros and cons, but that is the goal that we have, compatibility with Ethereum. And yeah, same developer experience as Ethereum. Currently, block times are 3 seconds, so confirmation is much faster. Of course, it's just a testnet, so it's also very cheap, basically free. Deposit from layer 1 to layer 2 usually takes about 2 minutes, and withdrawal might take around 10 minutes depending on the congestion of the network or depending on the prover capacity. And finally, I want to revisit this image that we had before, and just from the perspective of a transaction, end to end, like what happens when I open the swap. I click on swap. This triggers MetaMask, as you are familiar with, and I click confirm. So what happens when I click confirm? So basically, my transaction gets sent to the RPC endpoint, sent to the peer-to-peer network, and at some point it gets included in a block, and this block gets committed to layer 1. So what you need to understand is that the transaction is going to be actually available on layer 1, just as if you directly sent the transaction to layer 1. The difference is that it won't be executed by layer 1. From layer 1 perspective, your transaction is just going to be, data, some piece of data. And then for this block, which might have one or more transactions, we start the proof generation session, as we do for other blocks. And at some point, we create a proof. So this P1 proof actually contains a proof, or proves the whole block, including your transaction. So your transaction was also fully verified. We checked that the execution was correct according to the EVM rules, and this is all captured in proof 1. So at this point, when we submit the aggregated proof, that actually proves all the state transitions in your transaction that you just submitted from MetaMask. At this point, your transaction and the block that it's included in is finalized in the block. So this is the same kind of workflow that we just discussed, but I wanted to kind of show you from a different perspective, from like what happens when you click confirm on MetaMask. And this is kind of the end-to-end life cycle of a transaction on Scroll layer 2. So that concludes this workshop. And what I want to tell you is that we want to really invite you to join our community. We want to build something open in terms of open source, but also culturally open community. And we want to focus on, the future of Ethereum, scale Ethereum, and we also want to make zero-knowledge technology, more approachable to developers, and also encourage you to learn this technology and build with this technology on Scrum. So thanks a lot for your attention, and we can answer some more questions if you have any. And until then, I have the sign-up form here again. And if you want to save the slides, then you can check the QR code on the right that you link to these slides. Thank you.
Thanks, Peter. So yeah, let's Hazel. Yeah, please.
Okay. All right. Thank you, Peter, for such an inspiring and full of information presentation from you. And people, please take your time and take a chance to sign up and save the slides from Peter. This is a one-time chance, so save the slides. Do not regret.
Your last chance.
Do not do that. Okay, I will give you about like 1 more minute to 4 p.m. so that you can save everything that you need to do. All right. I am so happy and also very glad that we have received so many questions on both YouTube and QuickCom today. I think like Peter and Jerry and other engineers of Scroll didn't really have enough time to answer all of those questions. So that is a good sign. All right. So now to prepare for the breakout room session, I will input the links of the 4 smaller rooms in the chat box for you guys. And what you have to do now is choose one link that you want to join. And talk to our trainer from Scroll. Ask anything you want, say anything that you need to say, and ask for the Buidl prompt, Scroll prompt, and any advice that you want. And all of our trainers will help you out. Okay, cool. I input the links in the chat box. And also the YouTube team will also pin the message in the comment section. Wait a second. All right. Have you guys all seen the links?
See you in
Oh,
the
about
breakout room.
yeah.
Yeah,
Okay.
please chat with us there for anything you would like to, whether it's about Scroll, about Layer 2, or even about yourself. We are more than happy to have a close interaction with you. So yeah, see you
Yeah.
in the breakout room, everyone.
Yeah. Okay. And
So yeah,
about the
this
NFT, so sorry about that. We only have 100 slots. So please come back tomorrow on our workshop number 3, also with Peter, and you might have the chance to get one. All right. So participants, please join the breakout room, and we'll remind you if we have to go back to the main room later. Okay. See ya. Trainers, please go to your link. We are back to the main room. Everyone, are you there? If you are there, please raise your hand or give me any emojis possible. I can see that Fanlu is back. Playfanho is back. Jerry is on the way back. Hi,
Hi,
Jerry.
Hazel.
How was your room? I think that she was in your room,
Yeah,
right?
correct. We have a very pleasant conversation in Chinese. Wow, it's so cool to see that Chinese is sometimes also works in some of the Southern Asia countries. Yeah, Southeast Asia role.
Southeast Asia is still together. I also had a very pleasant conversation with Peter to learn about his journey, his experience in blockchain in Web3, and like, yeah, it's so nice to hear from you guys. I mean, like, I think I also learned something, even though I'm not a very, professional dev. Okay, everyone is going back to the main room now, so let's wait for them a little bit. All right. So meanwhile, I will show the QR code to the Discord server of East Vietnam, and so that people can via that can join the Scroll channel via that. All right. Share the screen. Hope that everyone can see my screen now. All right. So Peter, is your next workshop on November 10th, which is on Thursday? Hey, Peter.
yes, on
Yeah.
Thursday,
Or
same
yeah.
time.
Mm-hmm. So what is the topic of that workshop of our third workshop together?
Yeah. So before you learn more about the higher level ideas like what are ZK rollups, how does scroll work under the hood. So Thursday I want to do like a more hands-on workshop, maybe using Remix or Foundry to write some contracts and deploy it on scroll. So if you're
Yeah.
new to Solidity development or if you've developed before but you want to see how it works on scroll, then welcome to join.
Okay. Cool. All right. And everyone, I when I was talking with Peter, he was like he was so glad to receive all the questions from you guys. Yeah. So please keep that up on our next workshop on Thursday, November 10th, uh, 3 p.m. VN time, and probably Peter will have more interactive activities where everyone can like communicate with each other, interact with each other. And don't forget that Peter is really looking forward to seeing you guys, connecting with you guys, talking with you guys, and sharing together. You know, sharing is caring.
Exactly. Looking forward
Yes,
to it.
yeah. Okay, it was so fun today. Okay, I think it was enough time for everyone to scan the QR code to our Discord. And in our Discord server, there will be a lot of like channels, like smaller channels, of other sponsors, and especially from of Scroll. Scroll channel is very active, so please join Scroll channel on our on East Vietnam Discord server, and ask any questions you want and ask for support if any. We are more than pleased to help you guys. Right, Jerry and Peter?
Yeah, absolutely correct.
Exactly.
Yeah, so before the section of today ended, please check at the chat station. Yeah, that is again the form to access our testnet. In the end, it will be permissionless, but in the current state, we still want you to register at the list so that you can get access to our testnet tomorrow, and you get to deploy your contract on it. So as a kind of a homework, if you are currently doing the hackathon, participating in the East Vietnam hackathon, please try and see tonight or in the Wednesday. I mean, we have a day off to see that if you can successfully deploy your contract on East Vietnam and a smooth test and tell us what you think. But if you have trouble deploying it, feel free to join again in our Thursday test workshop, also by Peter, and we can help you to debug your deployment process and get your project running on Grow testnet. Thanks.
Thank you, Jerry. Thank you, Peter. And thank Dave Van Ho and Wan Lee so much for joining us today. You guys have shared with us so many great and useful information. And yeah, please check Scroll testnet, and we'll see you on Thursday, November 10th.
Yeah.
See you
Thanks,
See you on
everyone.
Thursday.
See you on
Thank you.
Thursday. Come on.
Come
Bye-bye.
on. Come on. Bye bye.
Come on. Bye bye.
Hi, Chan, right?
Bye bye. Bye bye.
Thanks, Wei Fan, Liu Huan. Thanks. Bye bye.
Bye bye.